I'm dropping out.
Yes, Emma.
Thanks for supporting me, guys.
Okay.
Got it.
The x-intercept is the point on the graph where y is 0. So to find the x-intercept, you're going to take your equation
Plug in 0 for y?
and plug in 0
Wow.
for y. Now, do all functions have y or x intercepts?
Do they?
No. Some functions don't have x and y intercepts. Sometimes they'll only have one, or sometimes they'll have both, or sometimes they won't have either. So just keep that in mind. All right.
Okay.
To solve, we will add 2. And then we need to multiply the x plus 1 to the other side.
I am having such a hard time on this graph paper because I like writing in the little blocks.
Dang. And then I'm going to distribute the 2. So I get 2x plus 2 equals 1. Subtract 2, so 2x equals negative 1. And then x is negative 1/2. So you have an x-intercept at negative 1/2, comma 0. Now your y-intercept is going to be when x is 0. So you're going to plug in x equals 0 for x. These are usually easier to find. So I plugged in 0 for x. So I have 1 over 0 plus 1. So that's 1, because like 1 over 1. And then minus 2 is negative 1. So my y-intercept is at 0, negative 1.
How did you do that so fast? Whoa.
She is a math teacher.
You should be able to do that fast too. Hold on. Because I'm having such a hard time writing these in these little squares that I'm like taking forever.
Don't write in the squares.
I have to.
Jeez.
It makes me so uncomfortable
In
if I
each
don't.
individual square?
Yes.
You're so weird.
I can't do it though. Like I get like, what is it called? OCD if I don't.
Like each letter is going in a square?
Yeah.
Oh my god.
Mhm. Well, because if it crosses over the square, it's just
do all the
wrong.
parentheses then? Like if each letter on a square.
Well, you put the parentheses and equal signs can go over.
What do you mean?
In my red book.
Like when she
What?
says.
Oh, like write it.
What?
Yeah.
Oh, what? Leave
Alright.
me alone.
Asymptotes.
No.
Whatever is going to make this denominator 0 is bad, because we can't divide by 0,
You
right?
divide by 1 though.
So what x value makes that 0?
0. For no.
Negative 1. That is your asymptote. So when x is equal to negative 1, we have an issue. We can't do that because we can't divide by 0. And because we have that issue, that creates an asymptote at x equals negative 1, which I'm going to put in my graph.
How do you know x equals 1?
Whatever x value makes this denominator 0 is bad, because we can't divide by 0.
But don't you want to do that?
Another
though?
way of looking at that would be, since this is x plus 1, you know that's a horizontal translation to the left 1. So our asymptote that used to be at 0 is now left at negative 1.
Right.
Okay. Now, we also have this guy out here. This is a vertical translation down 2. If I could explain super quickly why that's a horizontal translation, it has to do with limits. Alright, so side note. If I take x values and I plug them in, let's say 2, I get 1 over 3 minus 2, so like a third minus 2, which is negative 1 and 2/3 or something. Let's say I plug in 10. I get 1 over 11 minus 2, which is negative 1 and 10 elevenths. Let's say I plug in 100, I get 1 over 101 minus 2, so that's like negative 1 and 100 101s. 101s. What's happening to this number?
It's getting bigger.
Actually, I think it's getting.
Bigger.
Well, smaller, but.
It is, so like 2/3 is like, sorry, 2/3 is like slightly smaller than like 10 elevenths, right? This is like closer to what?
Closer to the
Closer
whole.
to 1.
It's closer to 1.
And this is even
Very
closer to 1,
close.
right? So
Oh, yeah.
So it's getting
where
bigger.
is this number going? Like where's it getting closer
Bigger means
to?
slightly bigger.
It's getting closer and closer
So
to
it
the
means
asymptote,
To negative 2.
which is negative 2.
Right.
So that's what a limit is. A limit is like as we increase x, or as x increases towards infinity. In theory, if I were to plug in infinity, which I can't do because it's not a number, but
infinity beyond.
go with me here.
So that'll be the y asymptote, negative 2.
Yeah. If I were to plug in infinity, this fraction is going to be so tiny, it's basically nothing. And then when you subtract 2, you get negative 2. And that's why we have an asymptote at negative 2, because as I plug in x values, this part is getting
But
closer
that's not
and
possible,
closer to
though, is
negative 2.
Infinity plus 1?
No, that's what I'm saying. In
Oh.
theory, like if I could plug in a really big number or something. So you're,
What's the biggest number you know?
I don't know, like a Google Plus.
Well, like other than that. Like one of those like septillion things.
Yeah, I guess any kind of word with a prefix like that. Octillion.
Was that seriously the most?
Octillion? Probably.
Whoa.
Yeah,
Can
My
someone
cousin's
count
obsessed
that
with
high?
math, and he just like tells me all the numbers.
Many years.
you know, like billion
You're
is like pi, so it's like 2 million,
Oh yeah.
like, or it's like an extra,
So then trillion's tri, and quadrillion,
right? And
and
just
quintillion,
right.
and
Quintillion
septillion,
sounds like
No, you
Quentin's
missed
name
one.
with an
You
alien.
missed
heptillion,
Probably like-
sextillion,
Yeah, that.
septillion.
All right. Anyways, right.
Uh,
Thank you.
Very
So we're gonna
nice.
state the domain and the range. Now, it's like if you have your asymptotes, the domain and range are kind of easy. Whatever your asymptotes are, those are essentially your domain and range. Your domain is that x can pretty much be anything except negative 1, because negative 1 poses a problem for us. So there's 2 ways we can write the domain.
No, it's gonna be the infinity
The
thing.
easy way would just be to say x cannot equal negative 1. X can be anything, x can't be negative 1. And we usually put that in what's called set builder notation, which looks like this. Squiggly bracket, x is such that x cannot be negative 1. And I believe I showed you this at the beginning of the year, you just might not remember.
You want us to write it that way, or that's just the x is not even?
This is one of the options.
Let's just say that's not
Then
my
we have
option.
interval notation. So interval notation says x can be anything up to negative 1. So from negative infinity all the way up to negative 1, not including negative 1.
And then negative 1.
And then negative 1 to positive infinity. In between these 2 intervals we put, it's like a U shape, it's called the union symbol. And it just means like we're uniting these groups together. It's basically like a fancy word for and in math.
So why not just do that in regular writing?
That'd be funny.
Yeah, I mean I might as well.
Are you
And
sure
also-
to draw an infinity sign?
In Miss Coulter's essays. Alright. Okay, now our range is gonna be similar. So
These
for
are
range,
Oh my god.
we have to talk about y's.
Bracket
So
y line.
y
Write in a
line.
full sentence.
Y is not equal to negative 2.
There you go.
I like that one better.
Yeah.
You would.
No, no. No.
What? Okay.
Uh,
Well, that was not it. What?
Okay, in interval notation, we want
It's
to
bigger.
include everything up to 2, up to negative 2, and then everything after negative 2.
So which one do you want to see more?
I want you to know both.
All of it, all of it.
So
You need to know both.
So it doesn't include negative.
No. Because at negative 2, we have that asymptote, so it can't include negative 2.
Infinity.
Negative 2 universal.
To negative
Universe.
2.
Unite!
Negative 2 umbrella.
No, umbrella is different.
Negative 2 university.
Umbrella is different symbol.
I like
The
the
opposite.
bracket one.
Alright,
The
so then-
infinity just
So then we'll
threw
do
me
that
off
one.
my game.
What if I do that one then?
What
Can I
is
get
that
bonus
one?
points?
This is a different symbol.
What is
Is it
that?
actually though?
Yes, it's like the opposite. Here, look.
Holy crap! It's actually a thing.
So instead of and it's or. So instead of and it's or, right?
Set theory.
Set
Okay.
theory.
Union is like this.
Oh, and then Confederate is whenever you flip it to the right
What?
a little bit.
Intersection is this.
Okay. Yeah.
So when you're looking at the intersection,
Not Confederate.
you're
The
thinking.
Confederate would be
Remember
this
when
way.
we did questions
See?
like this?
And it's just one side.
That's intersection.
Oh, Lord.
Union is this. They mean different things. So
Think that.
umbrella means something else. All right. Anyways,
Wait, but look, you
we're
can
gonna
do.
graph our intercepts.
Huh.
So we have x-intercept of -1/2, which is like right here, and we have a y-intercept of
talk about
-1, which is right here. So those 2 points can be used to graph like swooshy thing number 1.
The U. Right.
So come in here and make these guys.
So the other one just the opposite. So it'd be like 2 and positive 1. Wait.
I don't know what you're saying.
How would you make it go on the other way?
So going the other way, we probably just need a little table.
Darn.
So we need to pick x values that are to the left of our asymptotes. If we pick values over here, we're just going to get more of these. So something less than -1, like maybe -2 or -3.
Less.
Do you like just flip
What?
Do you flip the points?
Flip the points. What do you mean?
Like, do you just flip it over?
You mean like, are they symmetric?
Yeah.
Kind of, sometimes, not always.
See, when I tried to flip them, it was just not right.
Yeah, sometimes they are. Sometimes they are in certain functions.
Oh my god, wait, yeah, because x is -2, and if you flipped up -1/2 upside down, it'd be -2. Right?
I don't know what you're saying. But wait, this is wrong. That's negative. This is -3. Okay, so when I plug in -2, I get 1 over -1. So that's -1 minus 2, which is -3. So when I plugged in -2, I got -3. So that's here.
-2.
And then if I plug in -3, I get
-4.
-2.5.
My little box makes
So
sense.
1, 2, 3,
1, 2, 3. It's pretty much the same thing.
Well, what it is the
You just like move.
I'm thinking how to explain it. This
It's like the reciprocal.
is the mirror image of that reflected across both of these asymptotes. So
So gosh.
there's like symmetry in the sense that the distance this point is from like here is the same distance as this guy is from here, and same with these. Like this point over here is like to the right 1/2 and then up 2, and this one's like the inverse of that. It's like to the left 2 and down 1/2. If that makes sense.
So if you draw a line like diagonally over.
Yeah.
I'm like, oh, that's not.
Well, I
that's
didn't.
not
I
an
didn't see the
apostrophe.
comma on the other.
All right. So let's try to find the x-intercept. So to find the x-intercept, you plug 0 in for a y. So
The
there's
problem is when I
nothing.
multiplied x by 0, it disappeared.
Right. Okay. So 0 is not equal to -6. So you're supposed to multiply the denominator over and you get 0 because
So-
anything times 0 is 0. So if there's a equation that can't be solved, that means there's no solution. So if there's no solution to the equation that we solved for x-intercepts, what does that mean?
There's no x
It means there's no x-intercept.
It means there's no answer.
The reason there's no x-intercept is because you have a horizontal asymptote at 0. Because if there's no vertical translation, the horizontal asymptote stays at 0. K is 0 because there's no plus k. So if there's an asymptote going through your x-axis, you don't have an x-intercept. In certain situations, in the next group of functions that we'll do, there are certain functions that will pass through a horizontal asymptote. But reciprocal functions, these guys don't go through the horizontal asymptote. Okay, same with inverse. So inverse variation and reciprocal functions will never pass through their horizontal or vertical asymptotes. We will have a y-intercept. So I got -6 over -3, which is 2. So you have a y-intercept, but no x-intercept. So we're able to have a y-intercept because our vertical asymptote isn't on the y-axis.
I'm going by 2s. This didn't work last time.
Our vertical asymptote is going to be at x equals 3. So all the way over here. Okie dokie. Now, our domain and range don't really change conceptually. It's still going to be everything except asymptotes. So x cannot equal.
I thought you said there wasn't an x asymptote. Why
3?
does it say 3?
No, there's no x-intercept.
Oh,
Did I say asymptote?
I
I don't know.
Yeah,
There's no x-intercept.
Okay.
There's an asymptote. Okay, so x cannot equal 3 or -infinity up to 3, and then the union of 3 all the way to positive infinity. It's our domain. And then our range is that y cannot be 0. Oops. Or -infinity to 0, and then again from 0 to infinity. Usually we have enough points with our intercepts to kind of like graph our swooshy thing, but we don't have that here, so we're going to have to do another point. I'm going to pick, -3.
That would just be negative. Yeah.
Because that would
it'd
be
be -1.
1.
Oh yeah, just the 1.
So -1, 2, 3, 1. So I'm just trying to pick stuff that goes into 6. We'll pick stuff that lets our denominator go into 6. But you can pick whatever, it's just that you'll have to graph fractions if you just pick willy-nilly anything. Which is fine. And then we want to pick some other points that are to the right of this vertical asymptote. So
4.
4 is a good one because that
then
makes
just like
the denominator
-6.
1, and then we just get -6. So 4 and then 1. I think that's like all the way down here. And then 5 should be good too, because that makes your denominator 2. So that gives you negative.
Why is yours all the way down there? Why is yours a different? Never mind. Don't worry. 5.
So if you're looking at this one compared to the last couple that we did, you'll see that the curves are like decreasing, like one's in the top right and then one's in the bottom left instead of like the other way that we've been doing. And that's because the 6, the -6 at the top is negative. So if that number up there is negative, then they go this way, and if it's positive, they go this way. Am I doing that right? Everything's backwards. This way. Positive this way.
Yeah.
Negative this way. Yeah. Okay. Questions? Sure. We're doing 2 sections today, 1 and 2. First section is on inverse variation. So before we talk about inverse variation, we're just going to really quickly remind ourselves about direct variation, which we did forever ago. We did it whenever we did like lines and stuff. So in direct variation, there's going to be some kind of constant of variation k. It's sort of like a slope, and that was the like direct relator between x and y. So if k was 2, then that meant y was going to be double x, every time. And if k was like -2, then y was going to be the negative doubled x every time. And that would be constant, like over and over and over. It wasn't going to change at all. With inverse variation, x is being divided by k, which means that the relationship between y and x isn't going to be like the same. It's not going to create that linear look. Here, if we were to make a table, let's say with this one, the change in the y's is the same, like with the change in x's, like they're changing the, if I increase x by 1, y is going to increase by 2. If I increase x by 1 again, y is going to increase by 2 again, and it's going to keep doing that, and that's what makes it linear or a line, direct variation. With inverse variation, these aren't going to look like lines. So in general, what an inverse variation looks like is either two kind of swooshy things going this way, or
But like one of those would be both those lines.
I'm having such a hard time with that green marker. Yeah, they go together.
Oh, okay.
Yeah.
I was
So it's like two swooshy things going that way, or two swooshy things going this way.
And they always like mirror each other.
Yes. Well, in inverse variation. Yes. If they're bottom left and top right, this is if k is positive, and this is if k is negative. Then they start top left, bottom right. And that's because if you were to like do this from left to right, this is increasing and this is decreasing. See how it goes from top to bottom, left to right. So that's how you know if k is positive or negative, which way it's going. And the reason what is with this marker? The reason it does that is because the function's gonna have asymptotes. If I have x down here, then that's posing some restrictions on my domain. I'm not allowed to divide by 0, so that means that x can never be 0 in an inverse variation function. And because x can't be 0, y can't really be 0 either, because if x times y is k, then there's no situation where, unless x is going to be 0, I can create some sort of 0 from that. Like, there's no number I could plug in here that would give me a 0 for y, because the only way we can really create zeros is with other zeros, and I can't have any zeros. So those are your two asymptotes, and that's why it kind of looks like curvy like this. So if you remember exponential growth and exponential decay, remember they kind of like curved towards your asymptotes. Well, in inverse variation, you're going to have one asymptote going this way and one asymptote going this way. And that's why the curved lines are kind of like going towards your x and y axes. So this asymptote is at x equals 0, and that occurs because I can't divide by 0. And then this asymptote is at y equals 0, which happens because I can't make y 0 because I don't have any zeros to make it with. So inverse variation always has those two asymptotes, x equals 0 and y equals 0. K will be whatever k wants, just depending on the situation. But it doesn't really affect our asymptotes. It just affects like the curvature of the swooshy thing. It might be like closer in here, or it might be farther away. So like could have been like closer in, or maybe like farther away. But in general, they all kind of have that same swooshy kind of shape. All right, so the first couple of things we're gonna do is we're gonna take a look at a table of values and determine if the relationship between x and y is either inverse variation, direct variation, or maybe neither. So to determine if something has direct variation, so if y is equal to k times x, then if we divide by x, that's what would give us k. which we kind of called a slope back then because it was linear. This means that given a table, if I take any y and divide by any x, I'm going to get the same k. So, for example, if I take 15 and divide it by 2, I'm going to get
7.5.
right. And that means that if this was direct variation, I should be able to take the next y and divide by its x. Whoops.
Oh my god, I'm like,
And get the same k. I should also get 7.5. Well, it's not going to be 7.5 because it's 7.5 divided by 4.
which is 1.875.
There you go. And so in theory, if this was direct variation, I should be able to keep dividing each y by each x and get the same k. Well, I'm not getting the same k, right? So that means that that first one is not direct variation. Now for inverse variation, this is an inverse variation equation. This is just a derivation of it. If you take x and multiply it over here, that's what gives us this. So in inverse variation, k is the product of x and y. So that means that in theory, I should be able to take the product of x and y and get the same k for all of these, if it's inverse variation.
Oh my god, I think it's true. Wait, how would you do it with like y equals k over x? Because like how do you find the k? Do you know what I mean?
Well, you'd be like 15 equals k over x, and then you'd multiply by 2.
Oh, so then you would, okay, you got it.
This is just this equation solved for k. Now, if we go ahead and multiply each x by its friend y, do we get the same k? What do we get here? 30?
By its friend,
30? Here?
30,
30. Here?
30, 30.
I think 30, yeah.
Okay, so if we get 30 for the whole time, then that means this is inverse variation
Got the answer.
because k was consistently 30 throughout. And that means that if we were to write an equation for this, like a function, it would be y is equal to 30 over x, because 30 is our k. Or in other words, if we multiply our x times our y, we're getting 30. Okay, so this would be our inverse variation function for this set of data. Or
Oh,
points.
because of the k over x.
Now, if you look at those numbers and you were to graph them, which I'm not going to because they're kind of like big, they would not make a line like direct variation. They would make a little curvy thing. They'd be really far away. So I'm not going to graph that particular one, but we'll graph some later. Let's look at this one. So we're going to see if it's direct, inverse, or neither. So I'm just kind of going in order. So we'll check direct. So to check direct, you're going to see if each y divided by each x is the same k. So 20 over a half, 40 over 1, 60 over 1 and a half. Are
It's
these
true.
the same number?
Yes.
Yes. What is the
What is, it's 40.
40? So because when we take y and divide by x, we get the same k, that means this is direct variation. And if we wanted to create a direct variation equation, it would be y equals 40 times x. Or like a slope of 40, that would create a line.
For the inverse part where you have x and y equals 30, it just means you can use either of those.
Like if we're writing a function, usually we write it like y equals. I just put this here because that's how we found 30. We took the x, we took the y, and we got 30. But we wouldn't write like an equation like that. That was weird. But it's the same relationship.
So
Now-
8 divided by 0.2 is 40?
It's 1 over.
Yeah, so 80 divided by 2/10 is 80 times 10/2. And these cancel, and you get 40.
Oh, okay.
Yeah, I know, it like seems weird, but it's true. Now neither would just occur if it wasn't direct and it wasn't inverse, then it's neither, then it's something else that we don't care about. Okay, suppose x and y vary inversely. that is fancy talk for use inverse variation stuff. It says x is 4 and y is 12. Now when they give you something like x is 4 and y is 12, they're giving that to you so that you can create a function. Yeah, so you can find k a number of ways. This is what the function looks like. So we're going to create a function that looks like this, but we're going to fill in k. If you want to find k, you can either plug those numbers into this function and solve for k, and then we have y equals 48 over x, or you could, in addition to this, memorize the fact that x times y equals k, and solve for k that way. Just take your x, take your y, multiply them together and get your k, and then plug it back in. Either way, it's the same math, and neither one's really easier or harder. This way, it's just you're kind of memorizing one extra thing. So we're solving for k, and then that's our model. So what that means is, if I want to know what y is when x is 7, I could plug it in. Or if I want to know what x is when y is 7, I can plug it in and then figure it out. It also means that we can graph it. So whenever you're graphing inverse variation, I'm going to ask you to stick in those asymptotes. So we know that because we're dividing by x, x cannot be 0, which means we have a vertical asymptote at x equals 0.
Do you know how big this is going to be so I don't want to get anything by graph?
I don't know.
I'm just going to...
We're probably gonna go by 2s, I think.
Okay.
And then we're also going to have a horizontal asymptote at y equals 0.
There's 2 of them always?
Yes. We're going to do a lot of different kinds of functions that involve asymptotes in this chapter. So it's important that you're not mixing anything up. This is inverse variation. It's a very specific type of function. So think like, I don't know, like poodle is a very specific type of dog, and a dog is a type of pet. We're going to do pets. This is like a poodle. Like we're going to do cats and dogs and all birds maybe.
Birds?
So don't like start mixing stuff up. Birds. Bird functions. All right. So I think I'm going to go by 2s. I'm going to make just like a super small table. On your table, I'm going to split this table like in half kind of. If you look, I'm like putting a little squiggly line here. I want at least 2 points to the right of my vertical asymptote and then 2 points to the left of my vertical asymptote. If you don't do like at least 2, you're not going to get a great look. And if you only have one side, then you're not getting the whole picture. Because k is 48, I'm going to try to pick numbers that go into 48 for x. Now we already have 1. They gave us 1, right? It said x was 4 and y is 12, so we might as well use that one. And then another point that goes in, right, or another x value that goes into 48 would be 6, so we can use 6 and 8.
12.4.
Now we want to use stuff, so these are over here. Now we want to use x values that are less than 0 or on the left side so that we get that. Because remember, I told you one curve's going to be here, one's here, or one's here, one's here. So we need the other half of the graph. So I need to pick negative numbers.
Negative 6 and 8.
So if I plug in negative 6 here, I'm going to get negative 8.
What did I just do?
I can also do the reverse. Like if I plug in negative 8, 48 divided by negative 8 is negative 6.
Wait, how did you get 6 and 8? Did you just like...
I was going to
I'm
say
just
negative
picking
4.
x values that are divisible, that go into 48.
Right.
Because 48's our k, and we have to do like 48 divided by those. I don't know how many thingies I have. 1, 2, 3, 4, 5, 6, 7. So I'm going to go by 2s. So 2, 4, and then 2, 4, 6, 8, 10, 12. So I have 1 point at 4, 12. And I have another point at 6. So 2, 4, 6, 8, 6, 8, right there. Okay. You can graph more points if you want, but basically what's going to happen is you're gonna connect those points, and then they're gonna slowly veer towards your asymptotes, like this. So they're gonna get closer to your asymptote. So if I were to extend an asymptote, we're getting closer and closer to your asymptotes.
So the
on the
negative
other
ones
side.
would be the other side.
So the negative ones would be on the other side. So I have a point at -6, -8. So 2, 4, 6, 2, 4, 6, 8. So that's going to be right here. And then I had one at -8, -6. So that's this one. So you're going to connect those and then just make them get closer and closer to your asymptotes. So again, if I extended my asymptotes, they should be getting closer and closer to those asymptotes. They should not touch the asymptotes, but they're going to look like they touch the asymptotes after a long enough time. Really, really, really close.
Mine just looks weird.
Alright, and the last thing it says, find x when y is 2. So we can do this now because we have our function. So all we're going to do is plug in y equals 2 into our function that we created. And then we're going to solve. So how do we solve?
Multiply by x.
Multiply by x. So that's going to be 2x equals 48. Huh?
And then divide by 2.
So x equals 24. There we go. So x is 24 when y is 2. That also means that there's a point at 24, 2, if you care about it. Maybe for another purpose. Questions?
When we have like a test or something, it would be like those kind of questions.
I'll give you the vocab. This is an example of, I didn't read the question yet, but it's either going to be combined variation or joint variation, where you're relating more than two things. So like in those last examples, it was just basic inverse variation because it's just x and y. But like most things in life aren't just two things. So if you think of like when you guys did geometry, area equals 1/2 base times height. That's 1, 2, 3 variables that are related, and this would be k, your constant of variation. Okay. Area of a circle. It's two things, but this one's special. He's squared, and this is your constant of variation. Okay, these are all examples of variation. You just don't like think about them the same way. This would be like direct variation twice. So like a type of combined or joint variation. Trying to think of another one that would maybe have 3.
Just like base times height times width. I meant length.
Oh yeah, like a volume. So like volume equals length times width times height. So that's like 1, 2, 3, 4. But there's no constant of variation. I guess the constant of variation would be 1. There you go. So like in general, when we're talking about real life things, it's not usually just 2 factors. It's multiple things that play a role in, life. It's not so simple all the time. All right, so I'm going to read this question. It says, the number of bags of grass seed N, so grass seed, like the seeds that you put in the ground so that the grass grows, needed to reseed a yard varies directly with the area. Like the area that I want to put the seed in. So there's a direct variation. Obviously, the bigger the area, the more seed I need to put down. But it varies inversely with the weight of the bag. So we had N, A, and W. I'm just like writing down all my letters. Now I'm gonna, before I read the next part, I'm gonna write some sort of function that relates those 3 variables. So reading it again, it says N varies directly. So when it says varies directly, you're going to put equals k times whatever it varies directly with. So in this case, A. So that would be a simple direct variation. N varies directly with A, or the number of bags of grass seed vary directly with the area that needs to be seeded. Then there's this other feature, W. And it says, and inversely with W. So inversely, think like multiplicative inverse. It's going to go on the bottom. Okay. And so that's like our function. Now, what we need to do is it's going to give us some numbers. We need to figure out what K is. So it says, if it takes 2 3-pound bags to seed 3,600 square feet, then how many 3-pound bags will seed a 9,000 square foot yard? Now you could probably figure this out without doing this part maybe, I'm not sure. But I'm gonna go through this process of creating a function so that we could maybe in theory use it for other things. So what we're gonna do is with this first piece of knowledge, we're gonna plug in all those values and solve for k. So the 2 is representing the number of bags. So that's gonna go in for n. The 3-pound is representing the weight. And then the 3,600 is representing the area. And we're gonna find k. So there's a couple ways you can solve.
Multiply by 3.
You can multiply by 3.
And then divide by 3,600.
Yeah, so we're gonna get a fraction. So when you divide by 3,600, you get
Something 6.
1 over 600.
Yeah.
That's our k.
When I like write out my equations, I like put a long line so it looks like I'm dividing both sides because it's just so much work to write the long numbers twice. Okay, cool.
Now, if we wanted to make a function, we would take our k and plug it back in. But with this particular example, this looks weird.
It looks disgusting.
Exactly, and we can't leave it like this. And in general, part of Algebra 2 is just knowing how to make icky things look pretty. So we're gonna make this look pretty. I'm gonna show you how we can rearrange it. So what you could do to make this look better is, so step 1, you would multiply by w. That would get rid of this. Okay. If you then combine these two things together, you'd get a over 600.
Right.
Because you know how to multiply fractions together. And then now we're gonna go back and divide by w again. Now when you divide by w, he will join Mr. 600 on the bottom because...
Does it have to be the n on the outside?
What?
Like, does it have to be the n on the outside, or can it
Yeah,
be
because the question says that n varies blah 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 blah. So n is like our dependent variable. So just to explain why w winds up on the bottom, if we take a over 600 and divide by w, that's a over 600 times the reciprocal, and that's why w winds up on the left. See? Okay, so this is our function. Now we're going to answer the question. So it says, how many bags that are 3 pounds will be needed for 9,000 square feet? So
1,600.
Wait, what?
Where are you gonna put the 1,600 that we got for k?
It's in there.
Oh, we like plug it in?
Yeah, we plug
That's
it
on the
in.
bottom end.
It's like, think you just solved for the slope, and then you like plug the slope back in and you get your equation of a line. It's the same idea, it's just not a line. And it's not really a slope, but it is like a rate of change. Alright, so let's plug some stuff in. So we got A is 9,000, and W is 3, and 600 is our K, so he's hanging out in here. And then I can
So what if it is-
divide by 3, get 3,000 over 600, and I can cancel some zeros, and then I get 30 over 6, and that's
5.
5. So we need 5 bags to seed our 9,000 square foot yard.